Good day, ladies and gentlemen. Thank you for joining us today. My name is Sean Naika. I'll be presenting on ETAP real-time PSMS system at Drakenstein. Just to give you guys an indication of where this local municipality is located. Drakenstein Municipality is located in the Cape Winelands, which is in the Western Cape province of South Africa. It is made up of the following towns: Paarl, Wellington, Gouda, Saran, and Hamon. To give you a high-level overview of our existing network infrastructure, we have 9 primary substations and 40 secondary substations at our municipality. The municipality also has a combination of legacy and new substation equipment. We have had limited visibility for our network, and we are upgrading all legacy equipment. Our vision is to embark on a digital journey by taking a phased approach so that we can create visibility of the electrical network, improve network efficiencies, reduce downtime, time of outages, and inadvertent tripping. We would also like to have a comprehensive unified vendor agnostic platform, which is easy to use whether you are a beginner or an advanced user or operator on our network. So our digital journey began with the first phase being creating visibility of 4 primary substations, integrating a multi-OEM substation into a unified platform, also to integrate both new and legacy technologies, the development and deployment of the digital twin, which is our ETAP model. Phase 2 was to create visibility on all other primary and secondary substations, integrate control functionality, integrate intelligent load shedding capabilities. Phase 3 is to integrate ETAP GIS, then afterwards integrate ADMS functionality, which is your Advanced Distribution Management System, then integrate OMS, which is your Outage Management System, and then to integrate your OTS, which is your Operator Training Simulator functionality, resulting in a robust digital twin, flexible system which is continuously evolving. The first part for us was to create a network model. So we've got a team that was appointed to do this for us. The following steps were taken to gain accurate measure of the network. Review existing drawings, update the outdated drawings, walkthroughs to various substations gathering information and data, use the ETAP app to accurately capture site information. Once all this information was gathered and put together, we then had an ETAP model put together, creating a digital twin of our 4 substations. Once the models were built, all data was entered in. The following studies were conducted in order to verify and optimize our network. We've performed load flow analysis to look at the power flows throughout the network to see the steady state operation of the network to ensure everything's running within its limits, able to see if there's overloads on cables and transformers, and to optimize our network. The second step was to perform short circuit analysis to determine the fault level calculations and to see whether they were within the ratings of the switchgear that's been installed in our network. The third part was to do the protection and relay coordination of our network to ensure that the system operates the way it should and there is no miscoordination in event of a fault that may occur. Once this was done, we then moved on to the hardware design part. At the substation level, we used IEC 61850 between the IEDs and RTUs for the newer equipment. And from the RTU to the master station, we used IEC 60870-5-104. And the architecture that we see on our screen right now is our existing architecture where we have our hot standby, our SCADA master, our operator and engineering workstations, as well as our HMI viewers. And at the substation level, we have our RTUs communicating with our substation equipment using IEC 61850. The substations where we have legacy equipment still in operation and IEC 61850 protocol was not able to be used, we used the Modbus protocol. And where no comms was available, hardwiring of contacts with appropriate voltage rating was used to bring in those signals. We still managed to maintain the RTU to master using the IEC 104 protocol. From this, we then had to program our RTUs. The RTUs that are used in our system on our network and at each of the substations is the ABB RTU540, ABB RTU560, and the Cytel DR from Schneider. All these RTUs were programmed accordingly to bring in signals into the system. From that, we will then request the consultant to provide various interfaces for us so that we can have visualization of our electrical network and understand what is happening. And we were able to create what-if scenarios and simulate them to see what effect it would have on the network and whether we could apply those changes or not. So one of the interfaces that were created for us was the ETAP real-time interface, which allowed us to look at our power flows, real-time power flows throughout the network. We then also have our HMI viewer, which is with advanced graphics. We also have our web interface, and we have a smartphone view. So any of the operators or engineers could easily access our network and view if there were any issues or if there was any problems and quickly identify them and notify the relevant team of where the issues were to resolve the problem. We also have the following views for our network. We have a communication viewer, which monitors the health status of the RTUs. We have an alarm viewer with different priority levels. We have an event viewer. We have a trend view, and we have a tabular view. All of these have made our visualization of our electrical network much easier, made it easier for us to identify problems and issues on one unified platform with vendor agnostic, and also allow us to optimize our network so to ensure that it's reliable and safe, and to reduce any issues that may occur, such as nuisance stripping on our networks. And we also have a very user-friendly interface, which allows beginners to advanced users to easily access the system and to do what is required. So with the ETAP PMS system, we have greater visualization of our network, better understanding of what is happening in our network, and we are able to monitor it and prevent unwanted or abnormalities from occurring on our system. And if anything does occur, we are able to quickly trace it and fix it and reduce the downtime. So we are quite happy with the system that we have, and we would like to improve with the other capabilities that are available on the ETAP real-time PSMS solutions. Thank you.